Hello and welcome back to the 6.2 notes. This is part 2 of our video, and we kind of need to switch gears a little bit and talk about something called integrating with respect to y. Okay, so every region that we calculate the area of might not be able to be calculated in terms of x, and it just kind of depends on what you're given. So there is a little trick to it, a little way to kind of remember how to do it. But the idea is that, if I'm trying to draw my slice, okay, if I'm trying to draw that slice, the thing that I need to do is be able to draw a slice that goes from one function to the next. And so if I draw this vertical slice here, if I go from, say, this point here up, I'm going from this function, x equals g of y, and I'm not hitting this function over here, x equals f of y. So, you want to be able to go across the function from either the left or the right and draw a vertical line from one function to the next. And that was the case in the last two videos, but in this case, we can't do that. So the idea is that I can draw a slice, a horizontal slice, from one function to the next, okay? But the difference is that instead of my thickness here being an x value, the thickness is a measure of y. So I would call this dy, okay? And the same thing applies over here. I can draw a horizontal slice at any point from the function, from one function to the next, going horizontally. In each of those, the thickness is dy, okay? And the same thing over here. I can draw a horizontal slice, and that's dy, okay? If I try to draw a vertical slice here, I could go from one function to the next, but I need to be able to do that over the entire interval, okay? And I can't really do that. So, I could, here I can go from, f to g, but here I would just go from g to g. And that's not going to give me a distance, okay? So, that's kind of the way we do it. So, the slice, let's write that. The slice must be drawn from one function to the other over the entire interval. Okay, so we also have to talk about a horizontal distance. Okay, horizontal distance. Okay, and so if I draw that same horizontal number line, here's 0, here's 1, here's 5. Okay, the distance between 1 and 5 is a distance of 4. Okay, but how do I get 4 using those numbers? And that's taking 5 minus 1. So 5 minus 1 is equal to 4. So now there's a difference. Now I have to go right minus left. Okay, and that's always going to be the case. And so over here, if we talk about this is always going to be, from this definition, this is going to be the right function. And notice how f is always on the right. So f minus g, that's on the left. So right minus left, okay? And so if I come down over here to example 3, now notice that I've got two graphs there. We can do this doing two different methods. And so the first method that I want to do, we have the graph of y equals x cubed, and that's this blue graph over here. This is x cubed. And then we have y equals x plus 6. And so this is the graph x plus 6. Now, what I want to do first is draw my slice. Now, I'm going to go ahead and do this with respect to x. But if I do that with respect to x, I notice that if I draw a slice from here, from the top function to my x-axis is the other one. So we're bounded by these three different graphs. So the x-axis, this line, and then this curve. Okay. So if I draw my slice here, this is dx. Okay, I go from this top function here to this function down here. okay? And that's just going to be the area under the curve because we're going from, this function down to the x-axis. And then here, if I look, we got to kind of think about this region because this region changes at 0. All of a sudden, if I drew a slice over on this side, then I go from this top function down to this bottom function. Now, we're still integrating with respect to x. My thickness is still dx, but we have to think about, can I draw a slice going all the way across, okay? And do I go from top to bottom? Now, that's the case here from -6 to 0, all right? I can go from top to bottom here, but from 0 to 2, I can't do that. I have to go from this top function, I have to switch functions. So this is going to require two different integrals. So my area here is going to equal the integral from -6 to 0 of my top function, which is x plus 6, and then the bottom function is just 0. Okay, so every time that you're actually taking an integral, you are subtracting by the bottom function, which is 0. Okay, and then dx. Okay, and then I would have to add to that the other area over here where the slice changes. Okay, so now I have a new bottom function instead of just the x-axis. So I'm going to integrate here from 0 to 2, okay, because my intersection point is at 2, from x plus 6, and then I'm going to subtract off the bottom function, which is x cubed, and then dx. Okay, and you could simplify this, and this would give you the integral from -6 to 0 of just x plus 6 dx, and then plus the integral from 0 to 2, then I'm going to do -x cubed plus x plus 6 dx, okay? And, you could plug this into your calculator. I'm not going to do this by hand, but this area here would be an area of 28, okay? You can check that on your calculator if you'd like. But I'm just concerned about us, writing the integral. Now, if I come over here, okay, and try this again, I can do this another way. And what I notice is that if I go, I notice that if I draw a horizontal slice, then I can draw a horizontal slice from my right function to my left function, all the way across, the area. And so that tells me that I can integrate with respect to y. So I'm going to draw my slice here, and I'm going to call this dy. Now, we have to change this, okay? This was the equation y is equal to x plus 6, and this was the equation y is equal to x cubed. So now what I have to do, these are functions in terms of x, okay? Function y in terms of x. So I need to now solve these equations for x. And so from here, I'm going to then, if I solve this, I'm going to get x is equal to y minus 6. And this is the function that I'm going to use. Now over here, if I wanted to solve for this, I would take the cube root. So I get the function x is equal to the cube root of y. Okay? And so now I just want to write one integral. Okay? And so the area here would be the integral from, and now, okay, hold on. Now I got to change my bounds. Now my bounds, because I'm dealing with y, I'm integrating between 0 and then this is 5, 6, 7, 8. Okay, I'm integrating between 0 and 8. So my bounds have to be y values. Okay, so that is something different. So from 0 to 8, and I want to go right minus left. So this is my right function, and this is my left function. So I would do the cube root of y minus the entire function y minus 6. Okay? And remember guys, I'm integrating this with respect to y, so this is dy. All right, so the common error with this really is just your bounds and then solving these for x. So, but let's go ahead and just simplify this real quick. And remember, I'm going to integrate from 0 to 8 of the cube root of y, and then I'm going to distribute my negative here. And so I'm just going to end up getting minus y and then plus 6, and this is dy. Okay, and you could integrate this by hand. Right now I'm just interested in setting it up, so remember this has an area of 28. You can check that and go from there. So let's take a look now at the last example. And, this is one, guys, where we can integrate this problem actually 3 different ways, okay? And so let's go ahead and first do this with respect to x. What I want to do here, I'm going to get a compound integral. I'm going to draw my slice here. Now what I notice is that from 0 to 4, I can draw a slice going from top to bottom to my x-axis, and then at 4, things change, and I have to go from this top function to this bottom function. So I have 2 different slices here. Okay, my variable is x, so these are both dx. And then, I'm going to label this as, say, y equals x to the 2/3 power. And then this function down here is y equals x minus 4. Okay, so let's set up our integral for our area. And our area is going to be the integral from 0 to 4. Okay, so I'm just finding this area right here up to 4. Okay, at 4 things change and I have a different slice. So that's just the area of just under x to the 2/3 power. So I'm going to write that as just x to the 2/3 power and then dx. Okay, and then I'm going to add the other area to that from 4 to 8. So I have the integral from 4 to 8 of my top function, which is x to the 2/3, and then minus my bottom function, which is x minus 4. And then this is just dx, okay? And we could simplify that. I'm just going to leave it like that for right now, just our ability to just set them up. This will give us our area. And our area is going to be 56/5. Okay, that's our area. Okay, now what I want to do is do this again. Okay, but instead of doing a vertical slice, I notice that I can do a horizontal slice from right minus left across this entire function. Okay, and so let me write this out. This is the equation y equals x to the 2/3. And this is the equation y equals x minus 4. Now, if I solve both of these for y or for x, I'm going to get the equation x is equal to y to the 3/2 power. And then here I would get x is equal to 4 plus y. Okay? And so now, if I draw my slice from, horizontally, okay, this is my right function, this is my left function, and I could set up the integral going from, now I got to think about my bounds for y, I go from 0 all the way up to 4. So this is one integral, so the area is equal to the integral from 0 to 4 of my right function, okay, which is this function right here, which is 4 plus y, and then minus my left function, so minus y to the 3/2. And then I would integrate with respect to y and say dy, okay? And again, this is going to be the same area of 56/5, okay? So you can do it 2 different ways, whatever you guys are comfortable with. Sometimes you have to do it with respect to x. Sometimes you have to do it with respect to y. Sometimes you have a choice, okay? And the choice is yours. Okay, so now let's look at this a completely other way. Okay, now what somebody else might see is they might see that I could just take this entire area under this blue curve. Okay, under the curve y equals x to the 2/3. Okay, and then one could see, so you could take this entire area between 0 and 8, okay? And so I'm going to do that. I'm going to take that entire area, and let me kind of shade that in real quick, that you got something like this, that entire area here, All right. And so the integral for that, which we know how to do, the area for that, is just going to be area is equal to the integral from 0 to 8 of x to the 2/3 dx. But then what I notice is that this area created here is just a triangle. And I could take the entire area and then subtract off this triangle, and that will leave me with the remaining area. So if I subtract off this area here of this triangle, then I'm just left with this area here. And so this is and you can just use geometry, okay? This is a 4 by 4 triangle. So you could take this integral, this entire integral, and then subtract off the area of that triangle, which is 4 times 4 all divided by 2, okay? And so really what you'd get here is the area is equal from integral from 0 to 8 of x to the 2/3 dx, and then minus, okay, that's 16 over 2, which is just 8. And that would give you the same area of 56/5. So there's a number of ways of doing these problems, guys. It just depends on how you set them up. But that is the important thing, is that we set them up and that we know how to do so correctly. Okay, here is your homework. Really, really want you guys to get started on that. So I hope you enjoyed this video. I hope it was informative, and we will see you soon. Thanks. Bye.